All right, let's dive into LeJEPA. It's a new SSL framework that's all about provable theory, not heuristics.
So the whole idea is tackling a classic AI challenge, learning useful representations just from raw data.
JEPAs are a great blueprint for this. They learn by predicting one data view's representation from another's. But there is a problem, representation collapse. So we've relied on this whole suite of complex heuristics to fix it. All these heuristics raise a big question. What should the embedding distribution actually look like for best performance? And here's the first big contribution, a formal proof. The uniquely optimal distribution is the isotropic Gaussian. This result holds for both linear and nonlinear tasks, giving us a solid axiom for principled JEPA design. So, how do we enforce this? Well, that brings us to SIGREG, Sketched Isotropic Gaussian Regularization. Now this is clever. SIGREG enforces the distribution just on random 1D projections, neatly bypassing dimensionality's curse. Here's how it works. Project embeddings, run an Ebbs-Pulley test for Gaussianity, then minimize that test statistic. The upshot? You get provable guarantees, linear complexity, and stable gradients. It just works, even at scale. So you take the standard JEPA loss, add SIGREG, and boom, you get LeJEPA, a complete principled framework. And the best part? No more brittle heuristics. The whole thing boils down to just one trade-off hyperparameter. Okay, the theory is elegant, for sure, but does it actually perform? Let's check out the results. Check this out. Training loss strongly correlates with downstream performance. Plus, training stays remarkably stable, even for huge models. And look at this. For specialized domains, LeJEPA's in-domain pre-training actually beats transfer learning from giant models. The embeddings also show this amazing emergent structure. You can see it capturing object boundaries, totally unsupervised. And this isn't a one-off. They validated the stability across more than 60 different architectures. Impressive stuff. So what's the bottom line? A theory-driven design can lead to simpler, more robust, and really effective SSL. Which leaves us with this big question. Is this the future? A move away from heuristics towards principled design?